Okay, so you're opening a restaurant, and the mean income, right here, the average income of the people around the restaurant have to be 85,000. So remember, you always start with the null hypothesis is always equal to something. So the average income is going to be equal to 85,000. Now, in the problem it says it has to be at least 85,000. So what we want to do is really prove that the income is higher than 85,000. Okay, so there we go. There's our null and alternative hypothesis. Now, letter B, type 1 and type 2 error. Let's think about that. So what is the type 1? The type 1 is when you reject the null hypothesis in favor of the alternative hypothesis, even though the null hypothesis is true. Okay, so that's the type 1 error. Now the type 2 is when you fail to reject the null hypothesis, even though this is not true. Okay, so that's a mistake. We think it's 85,000, but it's actually not 85,000. That's a type 2 error. Now let's think about the consequences of each type of error. Type 1, we reject the null hypothesis in favor of the alternative hypothesis, but it's a mistake. So what happens is we open the restaurant and people are not really making 85,000, so they can't afford our restaurant. We're probably going to go out of business or have to alter our menu severely. So let's think about the type 2. Type 2 is we fail to reject the null hypothesis even though the mean income is higher. So in that case, we probably would not open the restaurant in an area that we probably should open the restaurant, and we might have trouble finding a place that would support this type of a restaurant. So that's a type 2 error, or the consequences. Now let's go to letter C. Which alpha level would you use? So remember, the alpha level is equal to the probability of making a type 1 error. I really don't want to do that, because if I make a type 1 error, meaning I'm opening a restaurant where people can't afford it, that's going to be a disaster. So I probably go with alpha level of 0.01. I really, really don't want to make that type 1 error. So on this one, we are looking at alpha level that has a power of 78, and we want to talk about type 1 and type 2 error. What is the probability that that would happen? Now the type 1 error is a little easier, so let me draw a picture. So here we are. This is where we expect, and we have a 5% alpha level, so 0.05 out here. So type 1 error is when you get a value out in that area and you reject the null hypothesis even though it's true. That's a type 1 error. So you basically have a 5% chance of that happening. So remember, type 1 is tied to that alpha level. So like that. That's a good thing to remember. Type 1 is the same thing as the alpha level as far as that's the probability that you make a type 1 error. Now type 2 is a little bit more complicated. So power. The power of a significance test against a specific alternative is the probability that the test will reject the null hypothesis when the alternative is true. So it's like the sensitivity of the test. So let's just say, here's how it works. So let's just say we have this value here, but remember they talk about an alternative value. So let's just say there's an alternative value out here that's actually true. We just didn't know that. And then we have all of this area, right? So in this case, we've got 78, so it's kind of a whole new test, 78%. See all this striped area? That's the area, right? Remember the 0.05? We would reject the null hypothesis. So all in here. We would reject the null hypothesis, all of this stuff, 78%. The only time we would accept it is right here, this smaller area. And that's a type 2 error, is when we fail to reject the null hypothesis even though the null hypothesis is false. So, kind of complicated, but you know what we really need to do is just think about the power. Okay, here's how it works. You say 1 minus the power of the test. That's all we really need to remember. So, there's basically a 22% chance that we would make a type 2 error. So like I said, that's the important part. Remember this. 1 minus the power of the test gives us the probability that we would make a type 2 error. Okay. Basically, power is the sensitivity of the test. So what we say is that we correctly reject the null hypothesis using an alternative value. We were at 10%, but what if we used 8%? Would we still reject the null hypothesis? Yes, 64% of the time we would still do that. That is the power of the test, correctly rejecting the null hypothesis even though you use a different value than what you're originally using. Okay, letter B. How would you get a higher power? Now remember, the power is the sensitivity of the test, right? How good is the test? Well, I would think that if we take more measurements, right, that's going to give us more accurate results, and that's going to increase the power. So increase the number of measurements increases the power. Better data. Now let's go to letter C. So type 1 and type 2 errors are kind of related. So it would make sense that if you decrease from an alpha level of 0.5 to an alpha level of 0.1, okay. So the probability of making a type 1 error is exactly the same as the alpha level. So now we only have a 1% chance of making a type 1 error, which means that we would increase the probability of making a type 2 error. So here we are, and here's the power of our test. This picture. So let's just say, right in here, let's say that's 78% or whatever. I'm just making that number up. So now, if we're in this area, we would still correctly reject, right, the shaded in area, is we correctly reject the null hypothesis. So now if we have that's a type 2 error, is when we make a mistake. We're out in here and we fail to reject the null hypothesis. So if we increase, right, type 2 error is in this area, if we increase the probability of that type 2 error, we're going to go like this. So now we're increasing the ability of making a type 2 error. So that area gets bigger, which means this area over here gets smaller, which is going to decrease the power of our test. No longer 78, maybe it's like 72. Okay. So just to recap real quick, if we decrease the probability of a type 1 error, we increase the probability of a type 2 error. If we increase the probability of a type 2 error, we decrease the power. That might be some good stuff to write down.